Hi everyone, in this video we are going to look at some advanced kinetics graph questions. Right, so these are cases in which you might encounter in the exams, but it is quite difficult for you to get the answers because you cannot apply typical ideas to them. So let's take a look at these two different examples here. So I would like to start off with our concentration time graph for our reactants. So given the reaction of A gives me C, I'm going to look at this graph of how concentration of A changes with respect to time. So what we know is that if we see a curve that looks this way, we just simply have to take our first half-life, which is half x, given that the initial concentration of x, and we find 1/4 x, and the time taken, right, for these two timings should be the same. Right, so that is one technique that we can use. Right, so but what happens is, if you're given a graph, right, and instead of giving you enough values, I only give you all the way up to 0.3x, for example. Right, so if I only give you all the way to 0.3x, how do I prove that I actually have constant half-life? Right, so this is where we have to go back to our definition, that for first order reactions, the time taken for the concentration of the reactants to halve is the same regardless of your initial concentration. So what I can do is simply take this value of x and divide by 2 to find where my 0.5x is. So for example, this is my 0.5x, and I'll mark this value, and I can choose another value. So say for example, I can choose the value of 0.8x. So 0.8x over here, if I halve it, I'll get 0.4x. So when I read the distance from here to here, this distance should be the same as this distance over here. Alright, so that is the method in which you can use to answer questions like that. On the other hand, if we were to look at a product time graph, right, where this is C and this is time here, alright, and I'm not given numbers up to my magic numbers of 50% and 75%. Let's say I'm only given values up to, say, 70%. Right, so this is 0.7x. Right, so how do we go about answering this question? So first and foremost, we can look for the first magic number, 0.5, which is this number here. Right, 0.5x here. This is our 50% mark. Right, but we also know that the earlier idea of the time taken to halve the concentrations is regardless of the starting concentration for reactant time graph does not apply to a product time graph. So we have to find another method to answer this question. So the trick to answering this question is quite interesting. Right? All you need to do is to convert your product time back to your reactant time. So we know that at time 0, I got x of A and 0 of C. Then at time is equal to infinity, or when the reaction ends, it will be 0 and x. And if I were to look at another data point after the first t half, I'll have 0.5x of A, 0.5x of C. So you realize that the sum of A and C will always give you x at the end of the day. This is only possible if the ratio of A and C is 1:1. So what this means is that I can actually transform my product time graph back into the reactant time. So let's take a look over here. Alright, so let's say, for example, I choose a value of 0.6x. What this means is that if 0.6x is my product, A will be 0.4x. Then on the other hand, if A is half the concentration of another value, alright, then the previous value will be 0.8x, which means that if I were to translate it back, it will be 0.2x for C. So all I need to do is to look for 0.2x over here, alright, and I'll mark this point of the graph and this point of the graph, and so this shows me a t half, and the timing should be the same as the earlier one over here. So this is the method that we can use to answer product time graph questions and reactant time graph questions if we are not given enough information to work with them.